This is part 2 of section 8.3. We're talking about geometric sequences, which are ones that you multiply or divide the same number every time to get new terms. Like with arithmetic sequences, you're going to be asked to find the sum of the first however many terms of a geometric sequence. And just like what happens with the arithmetic sequence where there's a pattern that's set up and you get a formula for it, you get the same thing here. Okay, we can add the first however many numbers of a sequence if we know our starting term, our ratio, and our end value. Okay, so let's use this to find the sum of the first 12 terms of the given sequence. So we're being asked to find S sub 12. That means our end value is 12. Our A1 value is our first term here, which is 3. What is our R value? What are we multiplying by every time? Well, if I go to 3 to 6, that's multiplying by 2. 6 times 2 is 12. 12 times 2 is 24. So my R value is 2. So let's plug in here. A1 times 1 minus R is 2 to the nth power, so to the 12th power, okay, over 1 minus our R value, which is 2. So this is 3 times 1 minus 2 to the 12th power is 4,096 over 1 minus 2 is negative 1. So this is 3 times negative 4095 divided by negative 1. And this gives me a positive 12,285. So if I were to do this and I'd list out the first 12 terms and I add them all up, I should get 12,285. Okay, so let's look at this one. Find the given sum. I'm going to find the sum from I equal 1 to 7. So my first 7 terms. If I start at 1 and go to 7, it's 7 terms. And I have 4 times negative 3 to the ith power. Compare this to this. We have exactly the same pattern. We have something times something else raised to an exponent. Okay, so I probably have geometric. I'm going to list the first few terms to see what happens. Well, this is 4 times negative 3 to the first power plus 4 times negative 3 to the second power plus 4 times negative 3 to the third power. So, and then I'm going to keep going. I don't want to list them all out yet. I'm just going to look for a pattern. Well, this would be negative 12 plus 4 times 9 plus 4 times negative 27 plus so on. Okay, this is negative 12 plus 36 minus 27 times 4 is 108, plus so on. Okay, so it looks like my first term is negative 12. A1 is negative 12. Okay, what is my R value? To go from here to here, I multiplied by a negative 3. So my guess is negative 3. Let's check right here, and it looks like I am multiplying by negative 3 every time. So negative 12 times negative 3 gives me 36, times negative 3 again gives me negative 108, so that's correct. And my n value is 7, because I'm supposed to add my first 7 values. Okay, so let's use the formula. S sub n, so S sub 7 is equal to A1 value, which is negative 12, times 1 minus R, which is negative 3, raised to the nth power, and n is 7, And this is over 1 minus r. So 1 minus a negative 3. We're going to need to be really careful with our signs here. This is negative 12 times 1 minus, make sure you're using parentheses here, negative 3 raised to the 7th power is negative 2,187. 1 minus a negative is 1 plus 2187. And this is over 1 minus a negative 3 is 1 plus 3. So this is 4. Okay, so this is negative 12 times 2,188 divided by 4. Negative 12 times 2,188. This is negative 26,256. Now divide that by 4, and you get negative 6564. So if you were to list the first 7 terms out, add them up, you'd get this. Now 7 is fairly small, so you might be tempted just to go ahead and list them all out and add them up, and that's fine, it works. But if you were asked to add the first 40 terms, it's going to get very tedious, and the chances of you making a stupid mistake are high. So you want to be careful about that. Okay. Now, unlike any other kind of sequence we deal with a geometric sequence in certain circumstances, you can get an answer to add if you're adding up an infinite geometric sequence. Okay? Before, in arithmetic and geometric, we had a formula for adding the first n term. So it was finite. We are adding a certain number, and that was it. It did not continue. If it is geometric, under certain circumstances, you can find the sum of an infinite sequence. Now, in this course, they're not going to ask you to find the infinite sequence for anything that doesn't work. But for those of you who are going on in math, this works when your r value is between, your absolute value of your r is between 0 and 1. So if you're multiplying or dividing by a number that's between 0 and 1, some sort of fraction that's less than 1, some sort of proper fraction, then this thing will, what we say, converge to an answer. You don't have to worry about this right now. This is something that comes up in calculus, okay? But at least you've seen it before. You're not going to be asked to do anything where this doesn't work. But this can also help you out if you keep it in mind, because we're going to have to find our r value. And if you're asked to find an infinite sum, then you should get, your r value should be between 0 and 1 if you ignore the sign. Okay. So let's look right here. I'm supposed to add up this infinite sequence. Notice it keeps going on. There's no final value. Our formula is just s. We don't, since we're not stopping anywhere. And we get a1 over 1 minus r. Now, compare that to our regular sum. Now, what's happening here? It looks like this part just got dropped off. And that's because if this number is a fraction, if it's small, if it's between 0 and 1, and you keep raising it to larger and larger and larger exponents, then if this number is smaller than 1, this pretty much goes away. It gets closer and closer to 0. So what ends up happening is we are essentially multiplying a1 by a 1, because this ends up being very close to 1 minus 0. Okay? All right, so let's look at this. We're asked to find this infinite sum. We need our starting value. Our starting value is 1. Okay? We need our r value. What are we multiplying by every time? Well, if I go from 1 to 1/4, it looks like I'm multiplied by 1/4. If I multiply 1/4 by 1/4, does that help? Yeah, the 4 and the 4 would multiply to the 16. 1 times 1 is 1. 16 times 4 is 64. 1 times 1 is 1. I'm multiplying by 1/4 every time. Okay? 1/4 is smaller than 1. It's between 0 and 1, so this will work. So let's plug into our formula. The sum is equal to a1, which is 1, over 1 minus 1/4. Okay, this is 1 over 1 minus 3/4 is 3/4. Okay, now what does this mean? This is a complex fraction. What I'm going to do, this is equivalent to 1 divided by 3/4. A fraction bar is a division. Now keep it, change it, flip it. This is 1 times 4/3, which is 4/3. If you start adding these together and you keep going on in the pattern, you go out, out, and out, and you start using your calculator, you can see that your values are going to get close to 4/3 the further out you go.